Hello, everyone. Lori Gordon here with the Aerospace Corporation. We've heard some great presentations this morning all about AI and quantum. And interestingly enough, before we can deploy those capabilities, we need to go through test development. That's the first valley of death, and then also the deployment valley of death. So people always think there's just one, but there's really two. So we're going to talk through some lessons learned and best practices about how do you fail fast in order to deploy quickly. And we have two extra special people here who know all about this topic. We're actually doing a little roadshow. We had the same panel at Ascend, which was fantastic, so we must have gotten some great feedback from there. So we have John Reed, who's Chief Rocket Scientist at ULA. We have Wil Francis, CCO at Agile Space Industries. So you can read more about their bios in your app. So let's get started. So we're going to start with the big picture, John and Wil, and we're all focused on two big government initiatives right now for space, layered missile defense on the defense side and moon to Mars on the civil side. And so we're going to be needing commercial capabilities, obviously integration, interoperability, with government systems. So how do we set up a secure testing environment for space systems so we can fail fast to succeed first before nations and commercial companies send these systems into orbit? So just high level, moon to Mars.
Yeah, I think, there's a whole lot of different systems that need to be tested in those different scenarios. There's high-risk portions of those different missions that need to be proven out. And I think we're doing part of that by doing some experimental missions in space. But then I think the real question for this panel is how can, what can we do on the ground? And how can we be best prepared for launch and have the highest chance of success on orbit? And I think part of that is it's really a similar scenario on the ground as it is in orbit, in my view, where we need to be willing to fail fast. And being willing to fail fast can be difficult when you have large programs of high importance. Just like on orbit, we tend to want to design a test so that we succeed in that test, so that we meet that milestone and we move to the next program milestone. I think it's important to have the attitude of let's allow failure and let's design a test to find the unknowns and find the possible failure scenarios rather than designing a test so that we succeed.
So designing scenarios, that makes sense. John, thoughts?
Try it now. There we go. I wanted to build on your comment and say, actually, for me, I think there are three valleys of death. And the third one is actually one of the first ones, and that is the integration readiness and the ability to integrate. And so you go prove the technology. You then have to figure out, how do I know it's going to be integratable to whatever the operational systems or operational ecosystem are, and then you've got to get it to work successfully in space. The reason I bring that up is because, to your point, I think that first set of testing is really to prove out, do I understand what I know about the physics behind the system or the element or the new component? Then you've got to have a test program that says, do I understand the interfaces well enough to be able to integrate it into the system that I think is going to be how I'm going to bring it to space? It's also part of the challenge that we've had working with NASA and other government agencies when they go burn down risk for technologies and don't understand the operational side of things that I'm looking to ingest that technology to go do. And so that becomes part of the challenge that we have to move fast for these big systems.
Excellent. So now moving on to maybe some of the challenges as a first step. ULA and Agile Aerospace, commercial companies, NASA, other government entities have test beds and proving grounds, but sometimes there's challenges at the outset. Maybe there's like a long queue or a long wait, and particularly in situations where we're in a situation we need to move fast for Golden Dome layered missile defense. What are some of those challenges that you're seeing sort of on the ground at the testing site? has a capability that they'd like to put through a test bed and proving ground. But where's some of the friction that might happen, and how have you mitigated some of those challenges?
Yeah, I'll start by saying in my industry, which is chemical propulsion, in-space chemical propulsion, you know, a bottleneck is just the availability of those facilities. To vacuum test a thruster is a unique facility. It's not your typical vacuum chamber. It's a vacuum chamber that you can fire a thruster into and pump the resulting chemicals out fast enough, the resulting gases out fast enough to maintain a vacuum. And there just aren't that many of those facilities. We started, with our company, in order to develop thrusters, we had to first develop test stands, which is a massive capital investment. And that's a big barrier to starting a company. It's a big barrier to developing a thruster, just finding that availability of test stands. So one of the things we're doing right now to try to alleviate that more generally in the industry, not just for us, is we have a partnership with the state of Oklahoma to design and construct the Space Test Center. It's going to be in Tulsa, Oklahoma. And we have a grant from the state of Oklahoma and the city of Tulsa in order to build that facility. It'll be called the Space Test Center. And the starting point for that facility will be a vacuum test center, so that anyone in the industry can come use that facility in Oklahoma and use it to develop new rocket engines, but also use it for acceptance testing of existing rocket engines to kind of alleviate that bottleneck. And it's not just a development bottleneck, it's also a supply chain bottleneck, because generally in space we do acceptance test every engine before we fly it. Once we get to large enough volumes, we'll have the statistics that maybe we don't need to do that. But right now, we basically acceptance test every engine before we fly it. So that's just part of the supply chain. You have to have that piece of equipment in order to fly your engine. So that's something we're participating in and creating in order to alleviate a bottleneck.
So you're looking to partnerships to be able to develop more capability, at least on the testing side. That's great. I know that in the United Kingdom, there's a feasibility study about rocket test stands, and some of the options are, building off of historic sites. So you're bringing in, a historic, organization that's has their thoughts about that too. So, John, over to you.
So, if we could go ahead and roll the video. And I'll talk over it to answer the question. A little eye candy as we're talking about test and test environments and test systems. I think you raised a couple of really good points that I wanted to build on. One is when you get to that exquisite end product, the test that you're going to have to run is really going to be in a bespoke test environment. So the example here is our solid rocket motor for the new Vulcan. We did a test firing, and really, back to your point, it's our supply chain. Our strategic partner, Northrop Grumman, developed this generation of solids for us, and this is the final test before flight to go prove out that system was going to give us the thrust that we need, the impulse that we need, the burn characteristics that we anticipated, and designed the rest of the system to be able to accommodate. And so when you get to this point, it requires an expensive bespoke system to go test an expensive bespoke solution to the mission need. Ahead of that, you've also got sub-tier suppliers that are going to have to build things and go test them. To our earlier conversation, when you're even trying to understand, can I do this, and understand the basic physics, you're in a different test environment to be able to stand up and go show the characteristics that you want to have. And so you have a tiered approach to testing. When we think of government test facilities, those tend to be the bespoke end state for you guys and for some of the other engine suppliers I've worked with. They end up having their own in-house capability to go do small-scale things before they need to take the turbo machinery or the power pack to a more exquisite test stand to be able to go prove it out. And so it really becomes a hierarchy of test capability in the marketplace. the other thing that I wanted to build on your comment, and that was that bottleneck issue that we have becomes a business opportunity. And so that becomes, how do you find the right institute, the right partnership to go bring capacity into the marketplace to meet the emerging need? To the whole challenge we have with these giant bespoke systems, how real will they be in the time domain element of things, right? Is that funding going to be there in order to show I can close the business case to invest that kind of capital to create the infrastructure we need? And that's going to be a challenge that we have in the marketplace.
Interesting, yes. And just kind of comparing some government test sites to commercial test sites, we were looking at Marshall's rocket test. It looks like the Taj Mahal. And then you look at SpaceX, and it's just, very, very small. So there's definitely some innovation just in, the testing infrastructure that's going on. So in terms of defining qualified test beds, what makes something qualified to be able to test, and how does the companies that are trying to test a capability, kind of trust that test bed, a proving ground? We've kind of talked about this before, the idea of a flight-proven paradox, where anyone who wants to insure or acquire or invest in a capability, they want to see it fly. That's expensive, especially for newer companies who are just emerging across the space enterprise. So, what are your thoughts about what it might take to be able to develop the trust and even greater trust and confidence in these test beds on the ground, so that we may not need to fly to be able to prove to the investors that that needs to take place?
That's a great question, and I'll extend it a bit by saying it's a common worry in our industry that really holds us back. We are stepping into the test industry at my company at Agile, but we also have a part of the company that is a product division and does rocket engines. And on that side, you go to a test stand, any given test stand, and you say, here's the data we collected on that test stand. And people will associate that data with that test stand. But they'll question it. What would the data show if you tested it on someone else's test stand or a different national lab test stand? Because there are a lot of things in space. RF testing is another one I've run into in my career, where you characterize an antenna in a certain way and you show your data, but there aren't a lot of test standards that show you're meeting the need on orbit. So I think as a country, as a nation, we could, and broader than that, I think we could do a lot of work to develop test standards somehow. And the way you talk about it, I really like. It sounds like more of a general test for can we develop some sort of general set of tests that are widely accepted for qualifying a product or a satellite before it launches. And I really like that idea. And I think even doing that at a subsystem level is difficult. What tests can we develop that everyone can agree to? That's something we'd really like to do with our test center in Tulsa, is work with the industry, work with academia, and really the gatekeepers at the national labs, in academia, at the large organizations, and think through, can we come to a test standard, in my case for chemical propulsion, that even proves one aspect. How do we really believe that we tested minimum impulse bit in a reliable way, or thermal equilibrium, under certain operating conditions, to make sure that we didn't overheat valves and fry the valves? How do we develop test standards that will be universally accepted? It's really a question that I would love to answer. I'd love to hear inputs to. We'd like to do that because I don't think that currently exists today.
Maybe that's a question back to the audience during the Q&A. We can ask the audience this question. I don't know, John, did you have some thoughts there? Maybe what criteria?
Well, and actually, I was going to say, and for once we disagree. In my mind, a lot of the reason for test and what you're trying to accomplish is risk management. And so the test has to be designed to address a risk that you're trying to ensure doesn't get realized either when you go into the system level or when you go to operations in space. And so for a lot of things, it's not necessarily going to be that you have to have the one test that everyone does, as much as you have to understand the risks that you have and are there common ones that engine systems might have. Then you would want to have a standard around it. I do think there are some standards out there. I know Space Force and Air Force have done a lot of standards work in tests and certifications, but I wouldn't claim to even be, relatively knowledgeable about the content anymore. When I was doing GNC, I had a lot more familiarity with radiation testing and single event upsets and those kind of aspects for testing. But even then, the standards and approaches we used back then really aren't relevant to today's market needs, because you've moved from radiation hard to now fault resilient systems, I would call it, right? Where it's not just tolerant, but you're able to recover from the effects that occur in order to get the kind of lifetime you need. Part of the challenge we have is where those systems are going to evolve to may not even be stable from that perspective. It could be that we're not understanding some of the effects that we're going to be exposed to once we're on orbit, or as the contest continues into conflict or anything else in space. And so there are elements of this that we need to think through from a risk management for the domain as well as for the systems that we're trying to employ.
That absolutely makes sense. One thing that we are doing, Space ISAC is doing, stood up an ASC 100 group, Accelerating Space Capabilities 100. Essentially, it's a marketplace of test beds and proving grounds, test across the board, different domains, different capabilities, testing different capabilities. And we've overlaid a governance framework so that it has a set of parameters or criteria for each of the test beds and proving grounds. They fill out a profile against how do you do physical security, how do you do personnel security at your test site, how do you manage access, how do you manage the queue, the line, the priority, things like that, so that all of the test beds and proving grounds will have the same information they're providing to those decision makers, the gatekeepers that Wil mentioned, the acquirers, insurers, investors, integrators, and regulators, so that they have that same information. How do they, what does the test plan look like? How do they, what do the test results look like? How do they do the testing? So that the information's common, a common governance framework. Excellent. All right. So I guess, similar, to pull the thread a bit more, from an investor and insurer standpoint, what are those technical or operational benchmarks? And you all have, discussed these, whether it's a common standard or it's just understanding, what are the common risks. But is there anything else that, in terms of, an acceptable proxy for flight heritage, that we can provide to those investors and insurers, so that they have trust and confidence in the testing? Anything else we didn't cover there? Or are there acquisition or policy changes that could be made to put this into place? Maybe we'll go there. Got to bring policy in, people. Okay.
So I was going to jump in on the first part, but now we've got the whole policy can of worms. I'll try and mix these two together a little bit. I think there are aspects of policy that do have direct bearing, and part of that goes back to the risk and benefit. And so we need to be thinking from an insurance standpoint, it's going to be, what is the problem that I'm trying to make sure doesn't happen? What's the bad day that I can't afford for you to have frequently? And as we've learned from the insurance effects that occurred a couple years back, there isn't a lot of resilience in that insurance marketplace to be able to handle a lot of multiple failure scenarios or across the environment scenarios. And so I think, to your point, there needs to be some policy support for rapid expansion of capability where it's addressing the weakness in the market systems that we're hoping will be there to support expansion as we go Moon to Mars especially, but also for Golden Dome.
Oh, one thing, just, it pulls on the triad, the policy, technology, and economy, and we're going to hear about the economy later from George Pullen, so over to you.
Yeah, it is a really interesting question. What would insurers or investors view as a litmus test or a confidence builder for them to insure a product or invest in a product other than flight? And it brings up, I think insurers and investors are both very smart, and they'll look at all the nuance. They'll look at the TRL scale and, where do you fit in on the TRL scale with your technology, and have you truly qualified? And there's a, TRL 7 can be a gray area. Some people we try to get very specific about it, but there is a lot of nuance there, and they do dig deeply into that. But at the end of the day, when you're being judged for a mission or by an investor or by an insurer in a very quick scenario, which can often be the case, where you don't have more than 30 minutes or 15 minutes to make a decision on, am I going to invest in this company? Am I going to insure this company at the end of the day? You might just go back to that TRL scale. And maybe it would be interesting to think about a different level there, where we judge our own qualification in essence on a program, and we call ourselves TRL 7. But is there an external standard? Is there an external entity that is judging the level of your qualification and how good that qualification was? I think that does actually happen today, where, for us, example, if we have a mission that is with the Department of Defense and Air Force Research Labs and Aerospace Corps coming in and judging our qualification efforts, or a NASA program where NASA is judging those qualification efforts, that's one level of TRL 7. If we have a commercial mission where a commercial entity is judging our flight readiness, it's a bit of a different level, maybe a different type of qualification. Right now, insurers, investors have to understand all that nuance.
And I think, to your point, insurers and investors are going to be a little bit different in how they approach the marketplace. The insurers are really looking at, what's the risk posture that I'm taking financially? It's a pure financial downside mitigation. The investor's looking for financial upside, and it's going to depend on the kind of money that's being brought to bear as to what kind of risk tolerance they have for the downside. But in a way, you're looking at the two sides of the test environment. Did it work or did it fail? And so, to the earlier conversation, I think there is a need for having, especially, I'd characterize it as process control in my test environments and test beds. Because what I'm looking for is belief that if company X went in and had a test done and company Y went in and had a test done, that I can equate those results of those tests. Where I don't think that's always the case when you're talking bespoke systems and bespoke solutions that NASA does for Discovery class missions. There you're looking at burning down mission risk, but not necessarily looking to say, did the testing I did for this Mars rover versus that Mars rover equate in some way for me to evaluate the relative risk between those two platforms? They're just looking at, how do I get the insight I need to each of those systems? And so it's a different approach to how you do process control in your testing regime throughout the ecosystem going forward.
Interesting. It kind of reminds me of the standards development process and how that's managed in terms of certification, because there's 3 different types. You could do, a formal third-party certification by a standards organization, or you could do self-certification, or you could do a peer review certification. That's sort of in between. But let's move over to interoperability across facilities. So again, back through the lens of layered missile defense and Moon to Mars, we're going to need to scale capability to deploy, accelerate it. And that means we need to test, probably synchronously with systems of systems. So how do we coordinate testing across facilities? How was that done? How are we sharing data? I know, John, you had mentioned putting things into a digital environment at Ascend, so that might be part of this. But sort of how do we share data across test facilities, if that's something we need to do?
It's a great question. I think how we do it today is fairly disjointed, right? We have to follow all of our CMMC and make sure we're adhering to all those rules. And so we have to use kind of our standard systems. And, really, if a company is using external test services and doing part of that testing at one facility and part of that testing at another facility, there's no central system, right, where that data is shared. It's the responsibility of whatever company is managing those test results or the test effort to create the communication between those different facilities, and it's difficult. I would love for a way to share data anonymously. I think this is something we've talked about before, where if we could submit data in a way that doesn't key the data back to the original product that was tested, but anonymizes that data and create a database, where it's broadly accessible to the community. And, how accessible by what community, I'm not sure, but I would like access to it. And if I could put my data in there anonymously and start to build kind of better empirical models than we can as a company at Agile just with our own data, if we could anonymize everyone's data and put it in a spot and let AI interpret that data and show us empirical trends that we can compare our analysis to, that'd be a pretty awesome thing.
Luckily, Space ISAC's platform is enabling that for members of the community, because it's a trusted community. Everyone has NDAs, and so based on that trusted platform, we are looking not necessarily anonymized data, but just within that network to identify some of the anomalies that have been identified in testing, and to find solutions, within that community. So that's one thought. John, did you have?
I'm trying to remember the original question because I want to build off of both of them. I think I love the idea of anonymized learning. We actually had a conversation at a CTO summit last week where that was one of the weaknesses we identified as something that the community ought to come together to try and solve. And that's especially from a failure modes construct where you don't expose who had a failure, but you all get to learn from what went wrong and how it was missed or how it realized, if you will. So more to come on that. That's still a very hard nut from an IP standpoint to work through. But I think it was interesting what you were saying, Will, because really I see us, when it's our testing, as the collector of all those test results and the integrator of those test data to help provide value back to the organization and how we operate the system, how we manage development of the rocket, things like that. But if you think about Moon to Mars and the entire cislunar ecosystem that you're going to end up having, you end up in a different world where I now need two companies to, as I've been saying it, cooperate, where they're not working together, but they're not harming each other while they're working next to each other. And so that requires a different level of insight than we're used to having to have in an ecosystem that was built around bespoke missions and bespoke solutions. And so that becomes a nuance that we've got to go figure out in order to enable something like Moon to Mars to have that second segment where you get a commercial ecosystem to emerge that supports a financially viable path to going on to Mars.
Excellent. This might be a toss-up. Oh, that's right. A toss-up. Last question. So in terms of dual use, is there anything unique in testing that you need to think about, requirements for capability that's considered dual use? And or in terms of international, working with international partners or testing overseas, maybe leveraging, I don't know, an Australian test site or something like this. What kind of things come into play? ITAR, any of those considerations? Any? Onward.
All of the above. Yeah, I think the biggest challenge is dual use opens the door to ITAR. And even if you don't claim it to be dual use, you need to be cognizant of how others would claim it to be. And so just because you think you're just pursuing this benign science mission doesn't mean there isn't a dual use application that can cause trouble in the future. But I think really what we need to do is design this arc of testing in order to facilitate both dual use and bespoke solutions, either for commercial or for science. In that way, you can basically manage the relationships in a way so that you can protect the ITAR things that have to be protected, leverage the capabilities that are out there that you can leverage, but more importantly, recognize what we need to provide domestically to fill a gap that you wouldn't otherwise have to have if this wasn't a dual-use question.
Yeah, I mean, there's plenty of battle scars and pain we could talk about with ITAR and working internationally and those sorts of things, and it does present some challenges. I would say on the good side, there's a lot of mutual respect there. So between the different communities, dual use. So, if you're doing something in commercial, you're doing something with government, or you're doing something in civil space defense. As soon as you fly something or go through a CDR or even get a contract with NASA for a certain technology, that means something to the Department of Defense. It also means something internationally. Or conversely, if an organization has an international contract with JAXA or an international organization, and that organization has bought into a technology, NASA respects that, Department of Defense respects that. I think there really is a mutual respect there, and just knowing that the other party bought in is a good starting point. So I think that works well, and there is a good kind of collaborative nature there where there's a good mutual respect. Then when it comes to sharing actual technical information, things get more difficult.
Yeah, I did want to pull the thread a little bit on the policy piece of this as well. Every few years there's a new conversation around, do we need ITAR? Why are we doing ITAR? Our peers have advanced far enough that there is no risk there. I think there is always risk when you start thinking about global delivery of capability. I do rockets, and rockets can easily be attributed to missiles. And so even though all of my things are going to space and doing cool things for the government, for people, for science, it doesn't mean that I don't have to be cognizant of how I say things and what I say and even what questions I ask, because that provides insight and learning to foreign peers and competitors. The thing I want everyone to understand, though, is there are other smaller nation states that are not necessarily as tied and wedded to space that could benefit from the abilities or capabilities that we're talking about developing for Moon to Mars and especially for Golden Dome. And so we need to be a little bit circumspect when we think about relaxing ITAR or trying to be more open. We need to find ways to protect the information and still be able to do the collaboration that needs to be done. I think the trade secret agreements that we've started to put in place with certain countries are a good step forward for that. And we ought to be looking at things like that through policy.
Exactly. All right. Any questions? We're going to turn it back to the audience for any thoughts, perspectives, questions for this esteemed panel. Policy, technology, economy. Any questions? All right. Well, any last thoughts that we didn't get to that we might want to share with everybody?
Yeah, we can cue that other video and show it's kind of a different style of testing. So John was showing testing of solid rocket motors, very high thrust motors in atmosphere. When we're testing engines that only operate in space, if it's possible to test them in a vacuum, we do. And the higher the thrust level gets, the harder it is to test them in vacuum. But there is some video here of testing in vacuum. So these are, for example, that's about a 25-pound thrust engine that would be used for attitude control on a large vehicle, or main engine, an apogee engine, axial thrust on a smaller vehicle. This is more like a 75-pound engine, so a little bit larger engine that is a monopropellant engine being tested in a vacuum. And this is another atmospheric test. So these are the kinds of testing we're talking about where, like John pointed out, we can be looking for specific risks. Maybe there's a certain mission scenario that's difficult, and we're looking to burn down risk on that scenario. Or oftentimes you're just measuring specific performance characteristics of that engine. And that's where, from my perspective, you might measure something like I pointed out, minimum impulse bit. That is how small of an impulse can an engine put out in a given impulse. How small of energy can that engine put out? And that kind of tells you how precisely you can control the vehicle. And that's notoriously in the industry, if you measure that at one facility, you'll get one answer. If you measure it at another facility, you'll get another answer. And everyone in the industry kind of knows that.
Okay. Well, excellent. Thank you both. Thanks to all of you. This was the coolest show and tell ever, so appreciate it. All right. Thanks, everybody.